This is part A of the Lab 1. We're going to be running a hex board push button and the DE10 slide switches to change the values on the Mux display. We're going to drive that Mux rate through pin 17 of a 32-bit clock ladder, and what that means is we're getting 50 megahertz and we're dividing it by 2 to the 17, which should get us around 328, I believe, hertz. Now the first value we're going to put in is FEDC. So we get our switches. We're going to switch the least significant bit to C. It should be 1, 1. This will be turned on. The third digit would be a D. So that's going to be 1, 1, 1. Oh, I got a little twisted up here. There we go. 1, 0, 1, 1 for D, and let's make sure we got that one down. We got 0, 0, 1, 1. And then we're gonna hold down this one for the E, and then we're gonna load it. Now, as you see, we get FEDC. Now we clear. Next value we're gonna put in is EFBA. So we load in A and B at the bottom switches. And that was A, this is B. And then we're gonna get E and load that in. We get EFBA. Clear it. Now F987. Hold these two down and load it up. F987. Clear. F654. Would be these two outer ones. Load that in. Oh, must have not registered. Let's try one more time. There we go. F654. F321. And lastly, 0F10. Or 0F10. Let's depress all of these. F10. This is part B of Lab 1 assignment. I'm going to demonstrate the on-off switch. That's on. That's off. Reset. And if I hold reset, you see it stays at 0 solidly. Now, the digits displayed on the hex board represent a 16-bit counter value in hexadecimal, and as the 16-bit counter increments, the 4 7-segment digit displays value the different digits for the cathode. Again, we can stop it. Now currently we're running through pin 17 from part A, and I will now change the value for that pin assignment, and well, not pin assignment but pin, and we'll see how it looks. So I've gone ahead and switched the pin to pin 18 instead of 17 for the mux rate signal, and we can see that it is flickering. So at 2 to the 18, 50 megahertz divided by that, you're looking at 190 hertz, and we're getting a flicker. So that's one above pin 17, which was 2 to the 17. So we've gone up one pin, but we can see it's already flickering. And we have the on off still working, and it's cycling. I'll go ahead and turn it off and reset. Next we're going to do the pin 11, so I'm going to go ahead and compile that. Okay, now we are running the mux rate signal through pin 11, and so that's 2 to the 11, so 50 megahertz divided by 2 to the 11, you're going to get around 24 kilohertz. So we do not see that flicker, and instead we get the display appears more stable, and the brightness and appearance also remain essentially the same. And we can go ahead and run the counter. So that's on, and then we're going to go ahead and turn it off and reset. And next we're going to run the mux rate through pin 10 and see if there's any changes on that, and I'm going to go ahead and compile. This is now being driven through pin 10, the mux rate signal, and there's still no visible change versus pin 11. And right now we're basically doubled our mux rate signal, so we're around 48 kilohertz, and you'll see there's no flickering, still a stable image, and it's because we're well above the flicker threshold, so you won't see a flicker, a difference between 11 and 10, because the human eye can't really even capture that. So there we go, it's running, and now we're going to turn it off and reset. So now we're running back in pin 17, and you can see the flicker is no longer there. And we're going to discuss the upper and lower bounds. So when we did it through pin 18, that would be the lower bounds, and we started to get a flicker. And the flicker was caused because the divisor of the 50 megahertz divided by the 2 to the pin, which was 2 to the 18, was a low value because the divisor is a larger value, so you get a smaller hertz rate. And when you get that, you get a flicker because the rate is much slower. Now, as we decrease the pin value, you start to get a more stable image because the divisor is becoming smaller. And as it becomes smaller, the hertz value increases. So we get, when we were in pin 11 and 10, we were getting 48 kilohertz, 24 kilohertz. And then when we were in pin 18, we were getting a whopping 190 hertz, which is a lot smaller than the other values. So that's where the flicker comes in, is as a smaller hertz rate, because the pin is higher, then you get a flicker, and as the value decreases of the pin, you get a decreased value in the divisor, and the hertz rate increases.